Hey y'all. Hey y'all. So today's sorry. Today's objective is the triangle midsegment theorem. Triangle midsegment. So a midsegment is a segment connecting the midpoint of two sides. That's the word of. And so here is the theorem. If a segment joins the midpoints of two sides of a triangle, so if you have a segment that joins the middle of two triangles, or two sides of a triangle, then the segment is parallel. That symbol means parallel to the third side and is half its length. So the midsegment is half the length of the third side. So let me show you what that means. In this triangle, ABC, the midsegment, so this green line is a midsegment. It is parallel to this line, so it's parallel, and it's half the length. So if AC was 10, then DE would be 5. Let's look at this red one right here, EF. It's the midsegment, so it's parallel to this line, and it's half of the length. So if AB was 20, then EF would be 10. And then this purple midsegment is parallel to BC, and it's half of the length. And so we're going to work problems using the midsegment theorem. Alright, so examples. Here we go. A, we have a triangle, EFG, and then we have midsegments. We have some measurements. This is 60, this is 100, and this is 40. So the question is, in triangle EFG, HIK are midpoints. Find HI, IK, and FG. So let's talk about HI. HI is right here. And it is a midsegment, so it's half of this line. And so if this is 100, half of it would be 50. So HI is 50. IK is right here. So now we're looking for IK. IK is half of the segment that's parallel with EF. So if EF is 60, then IK is 30. And then the last one, FG, is this segment right here, FG. So this is the big segment. HK is half of FG, so we need to multiply this by 2 to get 80. So FG is 80. So we solve that using the midpoint segment theorem. All right, example B. In this triangle, AB is 10, so we find AB and we put 10. Now these little marks mean congruent, so let's just go ahead, we know that's 10, let's go ahead and put 10 there because we just know it. It'll probably make it easier for us in the long run. CD is 18. So my questions are find EB, BC, and AC. Well, we've already found BC is 10. EB. EB is right here. So if we're looking for this segment right here, we need to take 18 and we need to divide it by 2. We need to take half of it. So 18 over 2 is 9. So EB is 9. And AC is this entire segment. And 10 plus 10 is 20. So again, a few more examples of how to use the mid-segment theorem. All right, example C, copy it down. In triangle DEF, ABC are midpoints. So this says name pairs of parallel segments. Name pairs of parallel segments. So let's just start with DE is parallel. That's how you make the symbol parallel. DE is parallel to BC, or CB. DE is parallel to C, so we would do this. Means they're parallel. Let's see what else is parallel. EF is parallel to AC. So then you would do 2 arrows to show that they are parallel. And now there's one more pair of parallel segments, and that would be DF is parallel to AB. So you could do 3 arrows to show the parallel segments. 3 pairs of parallel segments. Alright, so example 4. Copy it down. Triangle XYZ is similar to triangle UVZ. So this symbol right here means similar. If it has an equal sign underneath it, it's congruent, if that's similar. So we have 2 similar triangles, a big one and a small one. So the question is, find the measure of VUZ right here, VUZ. We need to find that angle measurement. I see that these are congruent and these are congruent, so I know that that's a midsegment. It didn't tell me that it's a midsegment, but I know that's a midsegment because of my pair of congruent parts. Therefore, these lines are parallel because it's a midsegment. That's part of the theorem. If you know that they're congruent parts and that's midsegment, then you know the lines are parallel. Because now I know they're parallel, I know that these are corresponding interior angles. They're corresponding angles, and in similar figures, corresponding angles are congruent. So that means that this is 65 degrees. And you know that because these are similar triangles. Alright, so this last you try, you're going to do it on your own, but I'm going to get you started. You know that this is a midsegment because these are congruent and these are congruent. And we know that DE is half of AC. So you want to find X, find DE, and find AC. You're going to have to set up an equation, and there's actually 2 ways to do it. You can either take AC, so we know that AC is 2 times DE. So that's one equation you can set up. Or we know that half of AC is equal to DE. So I have helped you get the equation started. So there's 2 ways you could do it. If you like fractions, you could use a fraction. If you like whole numbers, then you're going to use whole numbers. But this is half of AC. AC is twice as big as DE. So it gives you 2 different methods to do it. I'm going to ask you to set up an equation and solve for X, find DE, and find AC, and we will go over it in class.